So good afternoon, everyone. My name is ChrisWales. I'm one of the SEs covering the south of the UK for Tintri. I'm here to give you a bit more of an insight, more kind of product-specific insight into how Tintri meets with kind of intelligent infrastructure. And from our VMStore platform, we deliver kind of hands-off automation and work natively with virtual machine within a virtualized data center. The intelligent infrastructure concept was introduced by my colleague Paul Haddo on the keynote. The basis of all of our storage solutions is intelligent infrastructure. Our systems have been designed to bridge the gap between the ever-expanding requirements placed on data center infrastructure, but where the kind of number of people and budgets and resources to manage them are flatlining. So by using insights, tools, and automation within the hypervisor stack and from the storage layer specifically, it's kind of our basis to kind of try and bridge some of that gap, allowing you to do more with less, whether this is by simplifying the storage related tasks, giving you greater visibility into what's going on at that layer, or allowing the storage platform to pretty much be autonomous and self-manage itself. So this isn't something we've just come up with. The marketing guys in a darkened room, as it were. It's been recognized as a Gartner category since 2018. However, we've been doing this and adhering to kind of the principles around intelligent infrastructure since 2009. So as a company, we've got plenty of experience within this space. Now, this is a more product-focused session based on three key technologies that we'll be covering across the three Tintri breakout sessions today. First of all, it's the VMStore. This is laser-focused on virtualization and SQL environments. It's been designed from the ground up to understand what a virtual machine is and the environment that it resides within. Now, our founder at kind of the Tintri side of the business was employee number 14 at VMware. And frustrated at how the storage interacted with VMware, he set up Tintri to provide a hypervisor-like experience from the storage platform, with levels of granularity and automation that other vendors out there, other storage vendors, are still trying to match. Then Teleflash, high-performance multi-protocol storage platform delivering simplified management, multi-protocol in its operation. It can do file and block. And my colleague Ross Cooper-Smith will be introducing this in more detail on the 15:30 breakout session. And then finally, a component of the VMStore platform that I'll be introducing, which is kind of some enhanced functionality specifically around storage for SQL servers, kind of taking the VMStore functionality further, moving it up the application stack rather than just kind of the VM-centric piece that we're going to be looking at today. But the SQL piece adds the ability to, rather than just work with the virtual machine, defining quality of service there, we can go more granular into the application stack, and in the case of SQL, into the individual databases, and allow quality of service to be set there, snapshot and cloning of individual databases, and giving you visibility of actually what's going on within the application stack. So giving you kind of full stack visibility. But all of our kind of products are about kind of giving you time back in your day within the kind of digital transformation. So it allows you to focus more on more meaningful business objectives. And there's a couple of quotes from our customers here that have adopted the Tintri VMStore. So it's giving them time back in their day. It's very much hands-off. So from the first quote here, a couple of hours a month looking at the dashboards just to check everything's okay. I mean, it alerts, it calls home, it tells everyone what's going on if there is an issue. The administrative cost of other storage platforms in here was massive. With the VMStore, it's allowed customer here to focus more on more strategic projects rather than the storage infrastructure, because it's pretty much set and forget. It's done its thing. And then the last one, which is the best of all, Tintri is the best employee I have. Okay, it's helping those customers to kind of not one less thing to worry about within their infrastructure. So for this session, we're focusing on the VMStore platform, which is optimized for virtual machines, be that kind of virtual infrastructure or VDI. So VMStore provides an autonomous storage platform that aligns with hypervisors like VMware, but equally that could be Hyper-V or others out there. But even though it's in a kind of an extremely powerful platform from a kind of performance perspective, it has simplicity at the core of its setup and operation and an ongoing day-to-day usage. So VMStore forms the storage layer component of kind of a three-tier virtualization configuration where you have the compute, the networking, and the storage. And it's available in either all-flash or NVMe options with our T7000 system that's been recently released. And capacity points ranging from a few terabytes. I mean, the lowest or the entry-level system, as it were, can be sort of low as 5 terabytes usable, compression and deduplication, even conservative rate that can take it to 10 terabytes. But we can scale capacities up to multi-petabytes and up to many thousands of virtual machines being supported on here. It's dense in terms of operation. I mean, we're starting at kind of a 2U system that could be half populated. But even in a kind of multi-system configuration, it's still got simplicity at its heart, keeping the architecture easy to understand and easy to manage. So there's no need to worry about kind of RAID configurations, policies and tiers. Have I got to create a new LUN for this particular virtual machine? It can be as simple as providing a single data store within the hypervisor stack, and then you just store your virtual machines there. The VMstore then takes over, does its thing, and ensures kind of even provision of kind of storage and performance resources to those devices. To those virtual machines, sorry. So let's kind of look at the hypervisor stack itself. So virtualization has been hugely successful, and it's transformed the way enterprises across the globe manage their estates. Now, the key entity within a kind of hypervisor environment is the virtual machine. This is where the application that your users connect to resides, and even though the users don't necessarily need to understand where the application lives, it's the user or the application manager that's going to be complaining if there's a problem or an issue with its service. So VMstore is unique in the storage market for the way it operates, in that it understands what an individual virtual machine is and what it consists of. So the configuration files, the individual VDISks, the virtual disks that make up that virtual machine entity, and where it also lives within the hypervisor stack, which physical host it's on, for example. What are the network paths to get there? Are there any hypervisor-based snapshots as well as storage-based snapshots in there? But I mean, virtualization as a whole has many benefits to kind of increased resource utilization rather than islands of storage, etc., versus kind of physical server architecture. But if we take a step back and we look at how things used to be, how traditional server storage environment used to be, there was a one-to-one relationship between applications and the storage they reside on. So dedicated performance from kind of dedicated server resources and dedicated storage. But it was pretty inefficient in terms of its operation, as you have islands of compute and storage that weren't being fully utilized. So hence the movement towards the virtualization environment. Okay, but the storage today doesn't work in the same way. We no longer just got that kind of one-to-one relationship. The storage is having to deal with multiple different application sizes. So we may have an SQL virtual machine, we may have a file server virtual machine, could be all sorts of other different virtual machines with different performance profiles that have different block sizes. Some may be read orientated, some may be write orientated. And you end up with this kind of IO blender effect. So everything's getting mixed together and the storage is kind of struggling to keep up. So that can result in congestion and contention, and ultimately that ends up with poor application experience for the user. Now, you don't have that kind of same level of control as you do with the hypervisor piece for the kind of the compute resources. So people took different approaches to kind of trying to mitigate this, and one of them was to kind of throw more performance storage at it. But that worked for a time, but the contention issue is still there. You're just not seeing it as much. So better management to the workloads is kind of key to actually resolving this particular issue. So if you look at it in a bit more detail, you can kind of see the multiple different virtual machines represented by the green, the blue, and the turquoise and grey virtual machines there. And we're getting on a, whether it's a LUN that's being provisioned or a share that's being provisioned, you don't typically have that one-to-one relationship. You have multiple virtual machines that are actually residing within here. Now, from VMware's perspective, it sees a data store. From the storage perspective, it's presented a set of blocks to the hypervisor environment. It doesn't necessarily know that there's multiple virtual machines in here. So the actual kind of construct layer that the storage platform can deal with and report on is the LUN, is this entity. It doesn't necessarily know about all these individual virtual machines. So we actually have lower visibility of each virtual machine or application, and it makes it a lot more kind of difficult to actually pinpoint what's actually going on. So if we've got a performance issue, do we know it's this green stack of virtual machines? Do we know it's the grey ones that are causing the issue? We can't see that because we can only see to the actual LUN level in kind of traditional server storage environments within the virtualization world as well. So it's very difficult to pinpoint what's going on. Now, some other vendors out there or some kind of system administrators went back to the old approach, but with shared storage in terms of carving up individual LUNs per application. Okay, but that has its own problems, or sort of system admins are also maybe grouping together like for like workloads. So they know that file servers are on one LUN, SQL servers are on another, and that kind of align the performance characteristics of each of the applications, but you end up with this kind of LUN sprawl. So and an increase in terms of management overhead by having multiple different data stores within VMware and then the storage layer below that to actually understand and manage. So it actually adds an additional management overhead in this approach, and it's massive by having to carve up storage arrays and then create many, many LUNs and data stores on top of that. So it's very, very complex. There are other storage vendors and also kind of VMware themselves have tried to add functionality to their platform to try and get to the same level of functionality that we already have in VMstore, and we have been delivering for many years. So VMware introduced vVols to try and assist with kind of enhanced manageability and visibility of VMs. Now, vVols were introduced to address some of the challenge back in 2011, but the adoption of it and maturity of this feature set of kind of functionality is still playing catch up to VMstore, with VMware only starting to really push vVols use since version 6.7, so relatively recently. So yeah, kind of going back into 2020. So it's a relatively recent push now. It's actually matured in terms of its functionality. And we actually added vVols support early on to the VMstore platform, but then realized we were already providing a more enhanced feature set. So we redacted it, okay, because we were doing things in a lot better manner. So, I mean, vVols, it does have some benefits. I mean, they've solved the kind of snapshot stun issue that occurs or used to occur with hypervisor-based snapshots. But it also brings its own set of challenges and management overhead and complexity to the solution. There's also an inconsistency between storage vendors and implementation. So running a mixed or kind of ensuring portability between different storage arrays that may be connected into the same environment becomes very, very challenging. And there's still no meaningful quality of service. So you're still left with this issue of resource contention within there as well. You may also have lots of management points as well. So if you want to enable snapshots, you need another virtual machine. So each virtual machine could end up with needing 4 vVols. So multiply that over hundreds of virtual machines. That's a lot of management points again. And then as the system scales, the kind of heart of the vVol infrastructure is based around a metadata database, which needs to be protected and managed. And if that's lost, then you lose access to your data. So there's inherent risk there brought in at scale with the metadata database if it's not protected properly. So the VMstore works in a different manner. So it understands what an individual virtual machine is. So it can solve the IO blender or the kind of contention issue, the snapshot stun issue, and complexity and management because it works at that individual virtual machine level and understands what's going on. From a setup perspective, it can be deployed in operation in 30 minutes. And if we step back to look at the vVols again, that could take days to deploy in a kind of 100 multi-thousand virtual machine environment. Now, as mentioned, our founder was one of the early employees at VMware. And his ethos was to try and make the storage act as a hypervisor. Okay, so they understood and allowed manipulation of those individual virtual machines at the storage layer, but still maintaining tight integration into the hypervisor stack. So it was also aware of its surrounding environment too. But because of the way VMstore operates, we can keep the storage management to a minimum with either kind of a single or couple of data stores if required, and we can store the virtual machines on there. Now, every virtual machine we create or is stored on the data store gets its own specific area created. And we can see from on screen at the moment, we actually analyze what's going on with those individual workloads. So we can see, for example, here on the left-hand side, we're looking at an SQL workload for this particular virtual machine. So we can optimize that specific area for larger block sizes, so 64K in this instance, to make sure that that area is optimized and we can allocate the appropriate amount of resources to ensure that virtual machine runs at its kind of optimum level, regardless of the workload type. Okay, because every virtual machine is getting its own area. We can then visualize what's actually going on with the kind of entire estate. So it allows us to get into kind of no more noisy neighbor scenarios, but also gives us a visibility down to the individual virtual machine. So we can make decisions based on kind of the internal kind of AI about what we should do with those virtual machines. So we don't get into that noisy neighbor scenario where it's difficult to work out which virtual machine is hogging resources. So performance can be predictable, it can be guaranteed, and it takes away that storage contention problem. But more importantly, from an administration perspective, it does this automatically. So if an application, for example, spikes in terms of performance, as some applications do from time to time, the VMstore will give it some leeway up to the point it will start to actually impact other virtual machines or workloads. At that point, it's the spiking application that's throttled. So it's only one application that is affected. So it's one ticket into the IT team, and it's far quicker to kind of root cause than trying to work out which application or virtual machine is causing the issue on shared storage. And we also provide real-time analytics, so building on the automated quality of service to assist with any level of fault finding we can to compare and contrast metrics on specific virtual machine workloads within the entire hypervisor stack. So you can see here, we've actually broken out where latency is occurring. So for this particular virtual machine workload, we can visualize whether it's contention at the storage layer, whether it's latency induced by replication, whether we've actually got a problem on the storage network between the storage and the physical host, or if it's actually at the physical host layer. So whether it's maybe over provisioned in terms of virtual CPUs and we're getting a lot of CPU wait time, or under provisioned in terms of RAM, it gives us that visibility to be able to focus our remedial efforts into the right area. So on a larger environment, you kind of avoid that it's the network team issue, or it's the server team's issue, or it's the storage team's issue, because you can see exactly where any latency is occurring and focus those remedial efforts in the appropriate way. So taking the telemetry information further, every night telemetry information is sent to our cloud analytics portal, which stores 3 years worth of telemetry data, allowing you to view historical trends in usage over time, be that kind of capacity-based, performance metrics, numbers of virtual machines, also down to the database level as well, with the SQL Integrated Storage option now. And also around the supporting environment, so looking at the physical hosts as well, so metrics around CPU and RAM usage. So it gives you a full picture of your environment, both on the storage, the performance, and also the kind of compute element as well. The no business stands still. They're always evolving, and the analytics portal also includes a powerful planning tool, which allows you to model kind of either organic growth on kind of what an average virtual machine looks like in your environment, or additional workloads that may be added in the future to the VMstore environment. So you can accurately plan for whether it's a 100-seat VDI project coming in, or it's a couple of SQL servers, or maybe it's organic growth with 200 sort of standard virtual infrastructure servers coming in. But it allows you to accurately model that to see what your current system will handle, and then you can model adding in additional VMstore devices to cater for that increased workload if it's maybe tipping over 90% of the available resources. So it allows you to accurately plan and forecast and have predictable costs and visibility into the future. So it eliminates a lot of guesswork and giving you that kind of accurate planning tool. Now, if we do need to add additional VM stores, then we're extremely scalable within the platform. So we can start with a heart-populated system that allows drive-by-drive expansion. So we can add maybe 1, 3, 5, however many SSD devices or NVMe devices to fully populate a system. But once we're up to a fully populated shelf, we can then add another half-populated shelf or a fully populated shelf, which can also be of a different performance profile as well if needs be. The benefits of the kind of multi-VM store deployment really play to the intelligent infrastructure functionality. So as mentioned before, we understand what an individual virtual machine is and what it takes for each VM to run optimally. Within a scaled out configuration, using that kind of metrics information we know about the virtual machine, we can make intelligent decisions about where that virtual machine should actually live within our architecture. So if we, for example, have got virtual machine A on VMstore A, and we see that it would actually benefit the entire virtual machine estate from maybe it's just a slightly lower latency performance profile by being moved to VMstore B, then we'll do that automatically. It's all with the aim of ensuring that each virtual machine gets the appropriate amount of resources to allow optimal operation. So the system is continually analyzing what's going on, moving virtual machines around to ensure optimal operation, and we're not getting any kind of hotspots across our environment, and we're getting kind of even usage of our resources that are available to us. And from a data protection perspective, as we're working down to the virtual machine level, it allows us options from the storage layer to provide protection to the individual VMs, be that synchronous replication for disaster recovery and automated failover between locations. That could be async replication as well over slower links. Could be replication to an S3 target, for example, or could be local snapshots. Now, each virtual machine, rather than each kind of chunk of storage, LUN or data store, can have its own protection policy defined. So we can almost run a kind of a gold, silver or bronze scenario where gold may be synchronously replicated virtual machines, silver may be async, and bronze may be just local snapshots. And that can be automated down to the kind of naming convention of the individual virtual machines. So, for example, if we prefix a virtual machine with gold, we can ask the system to look for anything that's got gold within the title, and it'll actually automatically apply that protection policy that we've defined. Okay. And then, as we mentioned, our snapshots are stun-free, no performance impact, and they're instantaneous as well. So we've already solved some of the challenges that have been seen in the kind of hypervisor-based snapshots for some time. Now, cloning. So it's taking that snapshot functionality further, so building, utilizing the snapshots and creating clones instantly. So we've got a very powerful copy data management engine, which allows the creation of clones within seconds from the snapshots. So whether it's for kind of testing purposes, whether it's DevOps, software development, we can spin up and tear down thousands of VMs within seconds. And one of our larger customers, Dropbox, does this in their development environment for QA process by spinning up and tearing down thousands of VMs every 15 minutes. And this is efficient in terms of its operation as well, because it's happening at the VMstore layer, at the storage layer. So it's not impacting the physical hosts and production virtual machines. So cost savings of development environments, as it can be done in an efficient manner on the same storage, on the same storage if required. Now, VMstore functionality is continually evolving, be that kind of optimization with the underlying sort of AI stack within the system, or kind of faster devices by utilizing NVMe, or additional functionality. So the next kind of logical step for us was to move up the stack, so above where the virtual machines are, into the application layer. So now we have application-aware storage. So the SQL Integrated Storage is supported today as the first option in that, along with VMware Tanzu support. And then this is going to evolve over time with addition of additional applications being supported. Now, I'm not going to kind of touch too much on this because there's a further breakout session later this afternoon with my colleague Sean, who will be looking at this in more detail. But it's kind of giving you the same level of functionality, but down to the individual database instance in this case, okay, with SQL Integrated Storage. Now, VMstore is tightly integrated into the hypervisor stacks, and we've talked a lot about VMware today, but the same goes for Hyper-V and other hypervisors. But one of the key points is around the design, how it mirrors the kind of hypervisor architecture from a management perspective. So it's simple to understand and work with. So this could be from the centralized kind of management plane from Tintri Global Center that kind of mirrors what vCenter Server does, or it could be managed from the vCenter plugin itself that's added from the VMstore to the hypervisor stack to vCenter, and allows integrated management with there. And then over the top of that, we've got the Tintri Analytics portal, which receives the telemetry information and gives you kind of the historical trending back over 3 years, or kind of forward-looking 18 months into the future. So in summary, VMstore is unique in the storage market space. It's really intelligent in the way it operates, whether it's the automated quality of service per virtual machine to ensure that every virtual machine gets the appropriate amount of resources to run optimally, the enhanced visibility it gives you in real time for fault resolution, or the longer term analytics allowing you to accurately plan or enhance protection that can be applied to each virtual machine. It's a simplified approach to storage within a virtualized data center, and gives you time back in your day that allows you to focus on more meaningful business objectives and be more efficient in your digital transformation. I'd just like to say thank you. And if you require any more information around intelligent infrastructure, then please visit our website or speak to Leah. Thank you very much.